Picture a world so distant it feels like a whisper from the edge of existence. A blue jewel suspended in the cold, dark void, 4.3 billion kilometers from the warmth of the sun. Neptune, the farthest planet in our solar system, has long been a symbol of mystery, its swirling storms and icy winds cloaked in an aura of untouchable serenity. But in the summer of 2025, the James Webb Space Telescope turned its golden mirrors toward this enigmatic giant and captured something extraordinary. A cataclysmic collision that shattered the illusion of Neptune's quiet solitude. A massive object born in the shadowy depths of space slammed into the planet's turbulent atmosphere, unleashing a spectacle of fire, shockwaves, and radiant energy. This wasn't just a fleeting cosmic event, it was a wake-up call, a vivid reminder that our solar system is a dynamic, ever-changing stage where beauty and violence dance in equal measure. Through Webb's infrared eyes, humanity witnessed a moment that redefined Neptune, not as a frozen relic, but as a living, breathing participant in the universe's relentless drama. Imagine the scene, a dark, massive object, perhaps a rogue asteroid or a fragment of a Kuiper Belt relic, hurtling through the void at tens of kilometers per second. It's cold, silent, and invisible until it meets Neptune's atmosphere. The collision is not a gentle graze, but a violent plunge, releasing energy equivalent to billions of tons of TNT. Webb's instruments, designed to peer into the origins of galaxies, caught the moment in stunning detail. Infrared images revealed bursts of heat rippling through Neptune's methane-laced clouds, shockwaves tearing across the planet's stormy skies, and luminous streaks briefly illuminating regions that had lain in shadow for eons. The planet, known for winds faster than the speed of sound, became a canvas of chaos, its atmosphere twisting and churning as it absorbed the impact's raw power. This wasn't just a visual spectacle, it was a scientific goldmine. For the first time, astronomers watched a planetary collision unfold in real time, offering a front-row seat to a natural experiment that could reshape our understanding of the cosmos. Neptune, often overshadowed by its flashier neighbors like Jupiter and Saturn, stepped into the spotlight. The impact transformed it from a distant curiosity into a dynamic world, one that bears the scars of cosmic violence and tells a story of resilience and change. As the shockwaves spread, they carried with them clues about the planet's atmosphere, its hidden interior, and the very nature of the solar system's outer reaches. To understand the weight of this event, we must first know Neptune. Discovered in 1846, not by sight, but through mathematical deduction, when astronomers noticed Uranus wobbling under an unseen gravitational tug, Neptune has always been a planet of secrets. It lies at the solar system's edge, where sunlight is a faint glow, and temperatures plunge to minus 200 degrees Celsius. Its deep blue hue, caused by methane-absorbing red light, gives it an otherworldly beauty, but beneath that serene facade lies a world of extremes. Storms that dwarf Earth's hurricanes, jet streams racing at 2,400 kilometers per hour, and a faint ring system that whispers of ancient collisions. Voyager 2, humanity's only visitor to Neptune in 1989, revealed a planet of dark vortices and icy moons, with Triton, its largest moon, stealing much of the spotlight. Since then, Neptune has remained a distant enigma, studied through telescopes but rarely prioritized for exploration. Yet, its position at the boundary of the Kuiper Belt, a region teeming with icy remnants from the solar system's birth, makes it a cosmic crossroads. Neptune is both a shepherd, guiding these objects with its gravity, and a target, vulnerable to their paths. The 2025 collision, captured by Webb, proved this in dramatic fashion, showing that even the most remote worlds are not immune to the universe's restless energy. The James Webb Space Telescope, launched in 2021, is humanity's most ambitious observatory. Its 6.5-meter mirror, coated in gold, captures light from the universe's earliest moments. Galaxies forming 13 billion years ago, stars igniting in cosmic nurseries. But its versatility is what makes it extraordinary. Designed to study the distant cosmos, Webb turned its gaze inward to our solar system and revealed Neptune in a way no other instrument could. Its infrared sensors pierced the planet's thick atmosphere, detecting heat signatures invisible to traditional telescopes. When the massive object struck, Webb recorded not just the impact's flash, but its aftermath. The spreading shockwaves, the warming clouds, and the chemical changes rippling through the planet's skies. This adaptability underscores why Webb is more than a telescope. It's a time machine, a storyteller, and a cosmic detective. The collision on Neptune wasn't part of its original mission, yet its ability to capture such an event highlights highlights its power to rewrite our understanding of the universe. The images it sent back are not just data points, they're chapters in a narrative of cosmic violence, resilience, and discovery. Each pixel tells a story of a planet reshaped, a solar system in motion, and a universe that refuses to stand still. The collision on Neptune is a treasure trove for planetary scientists. The impacting object, likely a dense, rocky body cloaked in ice, penetrated deep into the atmosphere before disintegrating in a blaze of energy. Unlike comets, which glow as their ices vaporize, this object was dark and cold, suggesting a Kuiper Belt origin, a relic from the solar system's chaotic infancy. Its size and speed ensured it didn't burn up harmlessly, but unleashed a cataclysm that sent shockwaves through Neptune's hydrogen, helium, and methane layers. These shockwaves offered a rare glimpse into Neptune's atmospheric dynamics. The planet's clouds, already roiled by supersonic winds, responded with bursts of heat and turbulence. Webb's infrared data captured how the energy spread, revealing patterns that computer models had only predicted. This real-world experiment showed how Neptune absorbs and dissipates massive injections of energy, offering insights into its weather systems and their resilience. The impact also stirred deeper layers, potentially reaching the planet's mysterious interior, where exotic forms of ice and fluid exist under crushing pressures. By tracking these disturbances, scientists hope to unlock clues about Neptune's composition, clues that have eluded us since Voyager 2's brief visit. The object's composition is another puzzle. While Webb couldn't directly analyze its chemistry, the heat and atmospheric changes suggest it carried a mix of rock and ice, possibly broken from a larger body like a dwarf planet. This collision delivered alien material into Neptune's atmosphere, subtly altering its chemistry. Over months and years, scientists will watch to see if these changes shift the planet's color, cloud structure, or density, like a drop of dye spreading through an ocean. Such observations could reveal how impacts shape planetary evolution, not just on Neptune, but across the cosmos. Neptune's collision isn't just a local event, it's a window into the solar system's broader dynamics. Positioned at the edge of the Kuiper Belt, Neptune acts as both a guardian and a target. Its gravity pulls in wandering objects, sometimes redirecting them, sometimes absorbing their impact. This dual role mirrors Jupiter's, which shields inner planets by capturing asteroids and comets. The 2025 event suggests Neptune plays a similar protective role, neutralizing threats that might otherwise drift toward Earth or Mars. But it also highlights the risks. If a planet as massive as Neptune can be struck, no world is truly safe. This impact also rekindles questions about the frequency of such events. Are collisions like this rare, or do they happen more often than we realize? The Kuiper Belt is home to countless objects, from tiny ice grains to mountain-sized fragments. Neptune's position makes it a magnet for these wanderers, and Webb's observations suggest such impacts may have shaped the planet's history, from its rings to its tilted magnetic field. By studying the aftermath, scientists can estimate how often these events occur and what they mean for the solar system's long-term evolution. While Neptune's collision is a distant spectacle, it carries sobering lessons for Earth. Our planet, though smaller and closer to the sun, is not immune to cosmic impacts. The 1908 Tunguska event, where an asteroid flattened 2,000 square kilometers of Siberian forest, and the 2013 Chelyabinsk meteor, which injured over 1,000 people, are stark reminders of our vulnerability. The dinosaur-killing impact 66 million years ago, which left a 150-kilometer crater in the Yucatan, shows what happens when a massive object slips through. Neptune's collision offers a natural laboratory for planetary defense. By studying how its atmosphere absorbed the impact, scientists can model what might happen if a similar object struck Earth. The data from Webb, shockwave patterns, energy dissipation, and chemical changes provide a blueprint for predicting the consequences of impacts on terrestrial worlds. This knowledge fuels efforts like NASA's DART mission, which successfully redirected an asteroid in 2022, and ongoing programs to track near-Earth objects. Neptune's sacrifice, observed from afar, sharpens our focus on protecting our own fragile world. The collision's effects may extend beyond Neptune itself. Its largest moon, Triton, a captured Kuiper Belt object with a frozen surface and geysers of nitrogen, could have felt the gravitational ripples. The impact's energy might have stirred dust in Neptune's faint rings or nudged the orbits of its smaller moons. While Webb focused on the planet, future observations could reveal subtle changes in this delicate system, offering clues about how impacts shape not just planets, but their satellites and rings. Triton, with its retrograde retrograde orbit and active geology is already a world of intrigue. If the collision's shockwaves triggered seismic activity or altered its icy crust, it could spark renewed interest in exploring this moon. A dedicated Neptune mission, equipped to study both the planet and its moons, could build on Webb's discoveries, mapping the long-term effects of such impacts and revealing how they sculpt entire planetary systems. Neptune's collision resonates far beyond our solar system. Webb's primary mission is to study exoplanets, worlds orbiting distant stars. Many of these are gas or ice giants, similar to Neptune, and their atmospheres bear the scars of ancient impacts. By analyzing how Neptune's clouds, chemistry, and magnetic field responded to this event, astronomers can better interpret the light signatures from exoplanets. A distant giant's flickering glow might now be recognized as the aftermath of a collision, not just a storm or a flare. Neptune has become a Rosetta Stone, translating the language of cosmic violence into data we can use to understand alien worlds. This connection underscores the universality of planetary processes. The same forces that shape Neptune, collisions, atmospheric dynamics, magnetic fields, operate across the galaxy. Each impact observed in our solar system adds a piece to the puzzle of how planets form, evolve, and endure. Neptune's collision, captured in 2025, is a gift to exoplanet hunters, offering a rare chance to study these processes in real time. The collision's reverberations extend beyond the visible scars on Neptune's atmosphere, reaching into the planet's enigmatic interior and its peculiar magnetic field, offering scientists a rare opportunity to probe mysteries that have lingered since Voyager 2's fleeting visit in 1989. Neptune's magnetic field is a cosmic oddity, tilted at a dramatic 47 degrees from its rotational axis and offset from the planet's center. Unlike Earth's neatly aligned field, this irregularity suggests a complex dynamo within, driven by conductive layers of ionic water, ammonia, and methane under extreme pressure. When the massive object struck, it sent shockwaves deep into these layers, potentially disrupting the delicate balance of currents that generate the field. Webb's infrared data, capturing lingering heat signatures days after the impact, hinted at energy penetrating far below the visible clouds, stirring regions where exotic fluids flow like liquid metal. Scientists are now monitoring Neptune's magnetosphere for subtle shifts, changes in its strength, orientation, or auroral activity that could reveal how such a violent event influences the planet's magnetic engine. These disturbances act like a cosmic ultrasound, offering indirect glimpses into Neptune's hidden depths, a realm where pressures crush water into superionic states, where hydrogen ions dance through a lattice of oxygen. If these changes are detected, they could confirm theories about the planet's internal structure, long debated but never directly observed. Beyond magnetism, the impact may have intensified Neptune's auroras, those ethereal curtains of light caused by charged particles spiraling along magnetic field lines. While Webb's instruments are not optimized for auroral imaging, future observations with other telescopes, like Hubble or ground-based observatories, could reveal glowing displays at Neptune's poles, energized by the injection of material from the impactor. This event transforms Neptune into a natural laboratory, where a single collision becomes a diagnostic tool for understanding planetary interiors, magnetic fields, and the interplay of energy across vast distances, bridging the gap between the tangible violence of the impact and the invisible forces that shape a planet's identity. Neptune's atmosphere, a turbulent symphony of hydrogen, helium, and methane, became the stage for a breathtaking performance when the impactor struck, unleashing a cascade of energy that reshaped the planet's weather systems in ways that continue to captivate scientists and dreamers alike. Known for its supersonic winds, reaching speeds of 2,400 kilometers per hour, and storms that could swallow Earth whole, Neptune's atmosphere is a realm of relentless motion, where dark vortices swirl and jet streams carve paths through methane clouds. The 2025 collision injected a sudden burst of heat and turbulence, like a stone dropped into a raging river, sending shockwaves that rippled across the planet's skies. Webb's infrared sensors captured this chaos in exquisite detail, bursts of heat blooming like flowers in the upper atmosphere, shockwaves colliding with existing storms to create new patterns of turbulence, and luminous streaks of plasma briefly igniting regions that had been dark for millennia. These disturbances didn't merely disrupt, they amplified Neptune's already extreme weather, driving ejecta into the planet's titanic storms and creating feedback loops that altered cloud structures across entire hemispheres. Scientists watched as the impact's energy interacted with Neptune's jet streams, some of the fastest in the solar system, spreading debris and heat in unpredictable ways, like ink swirling through a whirlpool. This real-time laboratory offered a rare chance to study how a planet's atmosphere absorbs and redistributes massive energy inputs, testing models that had previously relied on simulations. The impact also introduced foreign material into the atmosphere, rocky dust and icy fragments from the impactor that could subtly shift Neptune's chemical balance, potentially altering its blue hue or cloud opacity over time. As months pass, astronomers will track these changes, watching for signs of new cloud formations or shifts in atmospheric density, offering insights into how planets heal from cosmic wounds. This event also has implications for understanding planetary climates beyond our solar system, as exoplanets with similar compositions face their own bombardments from space. Neptune's response to this impact, its ability to absorb, adapt, and recover, paints a vivid picture of a planet not as a static orb, but as a dynamic entity dancing to the rhythm of cosmic forces. Its atmosphere a canvas where chaos and resilience create a masterpiece that will inform science for generations. The collision on Neptune is more than a singular event. It's a thread in the vast tapestry of the cosmos, connecting the ice giant's fleeting moment of violence to the broader narrative of planetary formation, evolution, and the ceaseless interplay of matter and energy across billions of years. Neptune, stationed at the solar system's edge, is a sentinel at the boundary where the sun's influence fades into interstellar space, a region teeming with Kuiper Belt objects that carry the chemical fingerprints of the solar system's birth 4.6 billion years ago. The impactor, likely one of these ancient relics, was a messenger from that primordial era, its collision delivering a payload of material that could alter Neptune's atmospheric chemistry, much as impacts shaped Earth's early oceans and atmosphere. This event invites reflection on the constructive power of destruction. Just as a Mars-sized body struck Earth to form the moon, this collision may leave lasting marks on Neptune, from subtle shifts in its cloud composition to potential changes in its rotational dynamics or axial tilt. Scientists are now exploring whether repeated impacts over eons have sculpted Neptune's rings, moons, or even its lopsided magnetic field, suggesting that such events are not anomalies but integral to a planet's life story. Beyond Neptune, the collision resonates with the study of exoplanets, many of which are gas or ice giants enduring their own cosmic bombardments. Webb's data, capturing the interplay of shockwaves, heat, and chemistry, provide a template for interpreting the light curves of distant worlds, where similar impacts may manifest as flickers or anomalies in their spectra. This event also stirs philosophical questions about humanity's place in a universe defined by motion and change. Neptune, once a mathematical ghost deduced from Uranus's wobbles, has now revealed itself as a dynamic stage. Its collision a reminder that even the most distant worlds are not eternal, but subject to the same forces that forged Earth's habitability. The impact challenges our perception of the cosmos as a static backdrop, replacing it with a vision of a universe alive with collisions, transformations, and stories waiting to be told. As scientists continue to analyze Webb's images, they weave Neptune's moment into a larger narrative, one that spans from the solar system's chaotic infancy to the distant stars, reminding us that every planet, every impact is a chapter in the universe's endless epic, a tale of destruction and creation that binds us to the cosmos in ways both humbling and profound. Beyond the science, the collision stirs something deeper, a sense of awe and humility. For centuries, humans have looked to the heavens for stability, imagining planets as eternal fixtures in a cosmic clockwork. But Neptune's fiery scar shatters that illusion. The universe is not a still life, but a living, breathing entity where worlds collide, atmospheres churn, and chaos reigns alongside order. To see a planet 4.3 billion kilometers away flare with the energy of a massive impact is to feel the pulse of the cosmos, a reminder that we are part of a story far larger than ourselves. This event also reframes our sense of time. On Earth, we measure history in decades or centuries. In the cosmos, a single collision is a fleeting note in a symphony spanning billions of years. Yet, it connects us to the past. Impacts like this one delivered water, organic molecules, and heavy elements to a young Earth, forging the conditions for life. Watching Neptune endure a similar blow is like peering into a mirror of our planet's infancy, a glimpse of the crucible that shaped us. The 2025 collision has thrust Neptune back into the scientific spotlight. For too long, the ice giant has been overlooked, overshadowed by Mars's rovers and Jupiter's moons. But Webb's images demand a reckoning. Neptune is not a static relic, but a dynamic world, a laboratory of storms, impacts, and mysteries waiting to be explored. The data from this event will fuel studies for decades, but they also ignite a spark for future missions. A dedicated orbiter, equipped with instruments to monitor Neptune's atmosphere, rings, and moons, could unlock secrets about the outer solar system and its role in our cosmic neighborhood. Such a mission would build on Voyager 2's legacy and Webb's revelations, offering continuous observations of a planet transformed by violence. It could map changes in Neptune's clouds, track chemical shifts from the impact, and study Triton's response to gravitational ripples. The collision has made one thing clear: Neptune deserves our attention, not as a distant afterthought, but as a key player in the solar system's ongoing drama. Why does a collision on a planet so far away capture our imagination? Because it speaks to our shared curiosity, our drive to understand the universe, and our place within it. The images from Webb are more than scientific data. They're a story of survival, transformation, and the relentless forces that shape worlds. They remind us that the cosmos is not a distant abstraction, but a living stage where planets endure blows, atmospheres heal, and mysteries unfold. This event also carries a subtle warning. Earth, like Neptune, is vulnerable to the whims of the cosmos. While Neptune bears its scars in silence, Earth carries the weight of ecosystems, cities, and lives. The collision sharpens the urgency of planetary defense, urging us to track asteroids, develop deflection strategies, and prepare for the day when our world faces a similar test. But it also inspires hope. If Neptune can absorb such a blow and continue its dance around the sun, perhaps Earth too can endure the challenges ahead. The James Webb Space Telescope has given us more than images. It's given us a narrative. Neptune's collision is a tale of cosmic violence, scientific discovery, and existential reflection. It's a story of a planet struck by a wanderer from the void, its atmosphere blazing with energy, its storms reshaped by forces beyond comprehension. It's a story of humanity's ingenuity, building a telescope that can capture such moments from across the solar system. And it's a story of connection, linking a distant ice giant to the questions we ask about our own world and the universe beyond. As the glow of the impact fades into Neptune's clouds, the planet resumes its quiet journey, but it's no longer the same. It carries the marks of its encounter, a testament to the universe's ceaseless motion. Webb, too, continues its vigil, its mirrors trained on the cosmos, ready for the next surprise. For those who witnessed this event, scientists, dreamers, and curious minds alike, it's a reminder that the universe is alive, unpredictable, and endlessly compelling. Neptune has spoken, and through Webb's eyes, we've heard its voice. The story of this collision will echo through science, culture, and imagination for years to come, a beacon of wonder in a universe that never stops surprising us.